These are the notes about the seasons. The second video will pick up with the moon. So this is just about the seasons. The seasons. The tilt of the Earth on its axis is 23.5 degrees. This tilt causes the seasonal changes. It doesn't have anything to do with the distance the Earth is from the sun. It's just from the tilt of the Earth on its axis. And then if you take a look at this picture here, if you imagine right here in the middle would be the sun. So the Earth is only halfway illuminated at any one time. Here with winter, you've got the North Pole pointed away from the sun. That's why it's cooler in the northern hemisphere in the winter. And then if you look at this picture, the North Pole is pointed towards the sun, so that makes it the summer. The winter solstice happens December 21st or 22nd. The North Pole is in total darkness for 24 hours because, again, it's pointed away from the sun. The South Pole has continual daylight because it's pointed towards the sun. The sun is at its lowest point in relation to the way we in the Northern Hemisphere look at it. Why do we have winter? There are fewer hours of sunlight during the day. The North Pole is tilted away from the sun, and the light rays are less direct. So I have a picture coming up in the PowerPoint that shows if you have sunlight directly hitting, it's very concentrated, it's brighter, therefore it would be warmer. But this is winter, so the light rays are scattered more, which makes it cooler. The vernal equinox. Vernal means spring. Equinox means equal. This happens in March, around the 21st or the 22nd. And again, that's spring. And the sun is directly over the equator. So the way I tell you all to remember it is equinox equal equator. At the equinox, it's equal parts of day and night, and the sun is directly on the equator. All the E's go together. Equinox equal equator. Every part of the Earth experiences equal hours of day and night. The summer solstice happens in June after we get out of school on the 20th or 21st. The South Pole is in total darkness because it's pointed away from the sun. The North Pole gets 24 hours of daylight because it's pointed towards the sun. And the sun appears at its highest point, again, because we on the northern hemisphere see it as being pointed towards us at that time. We have summer because daylight hours are longer, meaning the amount of light during the day is longer, not that we have more time during the day, just that the amount of daylight is longer. And the sunlight is more direct. Again, if you take a flashlight and shine it right on one spot, it's going to be bright in that spot. And because of that, that would make us heat up more. The autumnal equinox, there's that a word again. So equinox equal equator. But the autumnal one for fall happens September 22nd or 23rd. It's equal hours of day and night. Again, remember equinox equal equator. The sun's directly over the equator. And then taking a look at this picture, yours on your notes is just a little bit different, but it's the same type of picture. If we were to start up here at the top, in that blank that comes off this way of that picture of the Earth, just write in vernal equinox. And then think about equinox, equator, equal parts day and night. And then you come around, we're going through spring, coming over to summer. Take a look, the North Pole is pointed towards the sun, so that's how you can know that that's summer. And there's a blank that is between the Earth and the sun on your notes picture. You would write in summer solstice into that spot. And then we're coming through summer, getting into autumn or fall. And then there's that E word again, equinox, equator, equal. And your blank for that would be off this way. You would write an autumnal equinox onto your notes in that spot there. And then we keep coming around through autumn, getting into winter. And here is the winter solstice. And your line to write that is between the sun and the Earth, right here. Winter solstice in this spot right here. And we know it's winter because the North Pole is in darkness. It's pointed away from the sun. The South Pole is pointed towards the sun, so that means that they would be having winter in the northern hemisphere. And all these titles are done by northern hemisphere. Don't ever try to think about it as the southern hemisphere. And then here's that picture I was talking about. If you had the sun coming in directly at a 90-degree angle, you can see how the light is all stuck into one section, so it's brighter. That's why we're heating up more in the summer when we're getting light directly onto the northern hemisphere. And then as we increase that angle, which this increasing angle will come in handy later on, we're going to do another lab about something like this. As you stretch that amount of sunlight out into a greater area, you see how the light dims, which is why we stay cooler in the winter. And then if you're looking on your notes, I don't have a slide for this, but underneath the seasonal picture, it says at what latitude is the observer standing? If you're looking at the picture, you can see north, south, east, and west marked on that circle. The observer is right in the middle, and then it shows you the path of the sun as an arc across it. And it says the sun is directly overhead at noon. So you need to try to figure out at what latitude the observer is standing. And I know we haven't talked about latitude just yet, but where might the observer be standing if the sun is going directly over his head? Should be at the equator, because if the sun is going directly overhead, he's got to be at the equator, because it's showing you he's standing at where north, south, east, and west all intersect, and the equator is directly over his head at noon. So make sure you're filling in how you know as well. And then there is a second video that picks up with what is the moon. So go ahead to that second one so you can get the information about the moon.